Hello viewers and my dear students. Welcome to session 1 of problem 3, that is demo on CNC manual part programming for a basic milling profile involving contouring and rectangular pocketing using Demo-Fanuc Milling Simulation software. These are all offline video help files prepared by Dr. B. Gurdhar, former professor and head Department of Mechanical Engineering, Bangalore Institute of Technology, KR Road, Bangalore 4, presently working as professor at the Department of Mechanical Engineering, Nitya Meenakshi Institute of Technology, Yelahanka, Bangalore 64. Okay, now as I've said here, this problem, what I'm doing right now is totally concentrating on writing G&M codes for a given milling profile. Okay, in this session 1, I'll be concentrating on writing G&M codes for the given milling profile. This milling profile is this way. This I'll be telling you. Okay, in session 2, I'll tell you how exactly to simulate this for correctness. Okay, using Fanuc Milling Simulation software. Okay, in the session 1, as I just now said, I'll concentrate only on the programming part using G&M codes. See here, there is one profile here which is similar to problem 2. This is, of course, this is same as a previous one. This has, as you see here, this is a profile. Okay, this is a profile. The profile means, profile or contouring means the tool has to go along this profile. Okay, once it goes, this goes along with the contour also, that is along this profile also. As you can see here, this is a profile, this is R profile radius 50, this also R profile radius 50, this is R profile radius 60, this is R profile radius 60. Okay, now for profiling means the tool has to go along this profile. Let us say from here to here, here to here, here to here, here to here. For that, I have clearly told this is contouring or profiling 4 mm width or 0.5 mm depth. 4 mm width should be the cutter, 4 mm diameter should be the cutter, so that it will be 4 mm width will be the slot cut and the depth of cut on the billet will be 0.5 mm. And this is a rectangular pocket, and as I've given here, it is 40 by 30 rectangular pocket, and you are using 8 mm diameter vertical milling cutter to do this. This is a rectangular pocket. Okay. Now, as I said, this involves profiling like this, profiling and contouring like this, and also pocketing. That means this entire area 40 by 30 has to be, the material has to be removed in this 40 by 30 area. The complete material has to be removed to a depth of 6 mm. 6 mm depth it has to go in steps of 2 mm. It has to first dig a hole, that is 2 mm depth, then 4 mm depth, then 6 mm depth. That is the way it should go. Now you see here, now carefully, first I have written the profile again here. A, B, C, D I have written. Okay, that is all I start from A, 0, 0. This is 60, no? 60, 0. 60, 60, 0, 60. Okay. Then once I have written this, the things will become easy. And as I said, this is an arc anti-clockwise. This is an arc anti-clockwise. This is an arc anti-clockwise, anti-clockwise. To do AB, using G&M codes, I am using G01. BC also G01. CD also G01. D also G01. For AB, that is R profile AB, G03 because anti-clockwise. For BC also G03 anti-clockwise. CD also I'll use anti-clockwise G03. DA also anti-clockwise. Then I tell you how exactly to do the pocketing and all that. Okay. Now you see here that is the manual part program starts like this. And as you see, once everything is completed, your profile, that is after simulation, it should look like this. Only if you're satisfied, then you start cutting in mass production and all that. This profile, for this profile and pocketing, we will do the program and test in the simulation software. If everything is correct, we will send the program to the machine and we get the similar components. Okay, that is the idea behind this. Okay, now you see it, billet X60, Y60, Z30. This is 60, 160, X is 160, Y is 160, Z is 30. 30 mm is the depth. That is this is the workpiece, no? Workpiece thickness is 30 mm. Okay. Length is 160, breadth is 160, 30. Okay. First tool, they have said For profiling, you have to use D04. Tool definition T1, D04. Same thing, you type it in the simulation software also. Tool definition T2, D08. This is for rectangular pocketing. It is 8 mm vertical milling cutter. They have asked you to use. G91, G28, X0, Y0, Z0 means you have to send the tool to the home position first. Okay, wherever the tool, let it go to the home position. See here, it is the home position of the tool is here. From here, it will come to this, do ABCD, then it will do this, it will do this, it will do this arc paths and all that. Then with the reference to this only, it will go to the rectangular pocketing all there, all with reference to A. Okay, then you see G91, G28, X0, Y0, Z0, it will send to the tool to home position. M06, T0101, that is the first tool. First tool is for profiling. Okay, M06, T0101, that is the first tool for profiling. M03, 1200, for profiling, I have used the speed 1200 should be the speed. G90, as I said, G90 is a very important command because all these coordinates have been calculated from the common origin, that is absolute coordinate system. That is from A, I have calculated all these distances from A only. That is why you have to use G90, otherwise it will not work. G00, X0, Y0, Z20. Please understand, G00, X0, Y0, Z20 means that G00 means rapid movement of the tool. The tool from the home position comes rapidly to A, that is 00, no? And it will be 20 mm, Z20 means 20 mm above the datum. It will be 20 mm above the datum. Z, if we start coming down and if it just touches the workpiece, Z will be 0. If Z becomes minus 0.5 or minus 1, it has gone inside the workpiece. If it is minus 0.5 inside the workpiece. Minus 1 means minus 1 inside the workpiece. That means cutting has started. Okay. Tool moves to A rapidly 20 mm above the datum. Okay. Next you see here. See here. G01, X0, Y0, Z minus 0.5. Now you see here. G01, that is linear interpolation. From it was above the datum. From that position, it has gone inside the specimen, inside the workpiece by 0.5 mm with a feed rate of 30. Okay. Then G01, X60, Y0, it tool goes to B. Then G01, X60, Y60, tool goes to C. G01, X0, Y60, tool goes to D. And G01, X0, Y0, tool comes back to A. That means this square profile has already been created with a depth of cut of 0.5. That you remember. Then G03, X60, Y0, X60, Y0, radius 50. That is this. Radius 50. This is radius 50. Okay. That is tool going to point B. Then G03, X60, Y60, radius 60. That tool going to C in an arc way. But here it is radius 60. Then G03, X0, Y60, radius 50 means tool coming to D. Okay. X0, Y60, radius 60. G03, X0, Y60, radius 50. That means here radius is 50. It comes to D. Okay. Then G03, X0, Y60, radius 50. That is coming to D. Then G03, X0, Y0, radius 60 means it will come back to A. And here the radius will be 60. But throughout, if you can give the feed. But if I don't give the feed, whatever feed I have given here, the same will be taken into consideration. Okay. Feed 30 it will take. Then that means the entire profiling is done. A to B, B to C, C to D, D to A. Everything I have given. B, C, D, A. And even arc profile also B, C, D, A. Okay. All these things are given. All with radius 50, 60, 50, 60. Everything I have explained. Then the profiling has already been done. Now I have to concentrate on the rectangular pocketing. Now after this profiling has been done, G00, Z20. The tool moves rapidly 20 mm above the surface, above the datum. This is called the datum, above the surface. It raises 20 mm above the surface and it goes to the home position. Tool goes to the home position. Okay. Now you see here, once it is that, now I'll call the second tool. Now the first tool has gone to the home position. Second tool will come. M06, T0202. That is a pocketing tool. That is, as you see here, it is 8 mm diameter vertical milling cutter. This is T0202 will be 8 mm vertical milling cutter. Okay. Then M03 S1000, I have given the speed to be 1000. Again G90, please understand, I have given everything with reference to A only. That is why G90, it's better you write. Otherwise, there will be some errors in the simulation. Then you see here, G00, X0, Y0, Z10. That means tool comes rapidly from the home position, that is the second tool, that is pocketing tool, comes to A and it will be standing 10 mm above the surface of the datum. It will be 10 mm above the surface of the datum, that is Z10. Now you carefully understand these two, G172, G173 will help you to do the pocketing, rectangular pocketing in any workpiece. Rectangular pocketing, any length, any breadth can be controlled using G172 and 173 blocks. These are all the programs. Okay. G172. I40, J30 means length of the rectangular pocket is 40, breadth is 30. That 40, 30. If I give I40, J40, it will create a square pocket. Okay. I40, J30, rectangular pocket length is 40, this is 30. Then K naught is, this is roundness. This K naught means as round as possible it will create. That is corner roundness. That is you better give K naught so that once it is cutting here, this corner roundness should be as less as possible. This will have to manage. P naught means roughing cycle. P naught is a roughing cycle. P1 is a finishing cycle. Now it is only roughing we'll do. P naught is a roughing cycle. You remember. Okay. We are not giving allowances and all that. Okay. Now Q2 is the peck increment. Peck increment is Q2. R naught is from the surface. From the surface it has to do. R naught compulsorily you do. Then come to very important. R naught is surface. From the surface of the job is this. From there this pocketing has to be done. That R naught you write. X10, Y15. Very important. This I have written PL point now. This point, this is 40. Totally 60 means X will be 10 here. This is 30 means totally it is 60. 15, 15 means 10 and 15 will give the bottom left corner. Depending on the X and Y positions here, this rectangular pocket can be pushed anywhere. If I make X60, Y60, the rectangular pocket will be created here. Since I want to create the rectangular pocket at the center, I have made X10, Y15. Be very careful. This, if I take X10 and Y15, automatically rectangular pocket will be at the center. Okay, X10, Y15, Z minus 6. That means total depth of cut should of the rectangular pocket should be 6. And in peck increment of 2 mm. Q2 means 2 mm. That means first it will cut 2, next it will 4, next it will 6. These things will be clear in the simulation. G173. I naught, K naught means no alliances. I am not given any alliance on base and on sides also. No alliances here because it's a roughing pocketing. P75. That means cut width percentage or 25% overlap between the first movement of the tool and this, and the again tool will overlap the over that with a overlap of 25%. S1000 means roughing spindle speed. R75 means roughing feed in Z. Roughing feed in Z means that is the spindle speed is R75. So, okay, F100 means roughing feed in XY. That is when it is operating here, when it is doing the pocketing, roughing feed in XY plane is 100 mm per minute. And B1500 and J200, B1000 finishing spindle speed, J200 is finishing feed. These two are not applicable because we are not doing any finishing operations here. It is only roughing operations because it is K, that is I have clearly given P naught here. P naught means first it will do minus 2, minus 4, minus 6 directly. I will not be leaving any alliances. Minus 2, minus 4, minus 6 directly it will do. That is why this B1500, J200 is just right. It will not be taken into account since I have written P0 here. Then after that safety, Z5, after cutting here, the tool would have gone deep inside the workpiece by 5 mm. Okay, deep inside by 6 mm. It will come rapidly, that is, it is 5 mm. Then it will go to the home position. Spindle will stop and then program stops and it rewinds. Okay, this is the G&M codes written for this problem, which is having a profiling as well as rectangular pocketing. Okay, these things anyway, we'll do the simulation of this and we'll verify the correctness. Okay, now we have come to the end of session 1. We'll start with session 2 shortly. Thank you very much for watching. Thanks friend, thank you.